student, now we'll start the second chapter for the M2, that is the sequence and series. Now in this chapter, in the first exercise, you will learn the geometric progression. In the last year, that is in the 10th standard, you learn arithmetic progression. In arithmetic progression, the difference between the two consecutive terms is constant. Now here in the geometric progression, the ratio of the two consecutive terms is a constant. Very interesting, this chapter is also this exercise. In this exercise, you will see that is to find the terms, decide whether the given sequence is in GP. Also, some word problems are also there. Now, in this video, I had covered the question number 1 to 10. I hope that you will understand all the questions very clearly. Now, let us start the geometric progression exercise 2.1, question number 1 to 10. Now see this. What are the main points for this chapter? That is AP, GP. Sum of the nth term of GP, sum of infinite terms of GP, HP, that is harmonic progression, AGP, arithmetic means, geometric mean, harmonic mean. Now start the exercise 2.1. Check whether the following sequence are in GP. If so, write their TN. Now 2, 6, 18, 54. These are the terms. Now here T1 is equals to 2, T2 is equals to 6, T3 is equals to 18, T4 is equals to 54. These are the terms. Therefore, T2 upon T1, that the ratio, that is a 6 upon 2, that is equals to 3. T3 upon T2, 18 upon 6, that is equals to 3. T4 upon T3, that is 54 upon 18, and that is equals to 3. If you see this, the ratio is a constant. Therefore, the given sequence is in GP. Now we want to find out the nth term also, but we'll find out when the question number 2 start. The given sequence is in GP, that is a geometric progression. Now next is T1 is 1, T2 is minus 5, T3 is 25, T4 is minus 125. R is equals to T2 upon T1, that is a minus 5 upon 1, that is a minus 5. R is equals to T3 upon T2, that is a 25 upon minus 5, that is a minus 5. And next is R is equals to T4 upon T3, that is a minus 125 upon 25, that is minus 5. The ratio is constant. Therefore, the given sequence is in GP. Now next is root 5, 1 upon root 5, 1 upon 5 root 5, 1 upon 25 root 5, and in this way. Here T1 is equals to root 5, T2 is equals to 1 upon root 5, T3 is equals to 1 upon 5 root 5, T4 is equals to 25 root 5. Now see this. R is equals to T2 upon T1, that is 1 upon root 5 upon root 5, then multiplied and reciprocal. It becomes, that is 1 upon root 5 into 1 upon root 5, root 5 into root 5, that is the root of 25, and it is 1 upon 5. The ratio is 1 upon 5. Next is a T3 up, T2 T3 upon T2, that I will change it, that is 1 upon 5 root 5, and again it is multiplied, and the reciprocal of the term is 1 upon root 5, therefore root 5 get cancelled, and you are getting 1 upon 5. Next ratio is T4 upon T3, that is 1 upon 25 root 5 upon 1 upon 5 root 5. Then again 1 upon 25 root 5 into 5 root 5, and again we are getting the ratio 1 upon 5. Now see this here, the ratio is a constant, therefore the given sequence is in geometric progression. The ratio is constant. One small mistake is there, that is a T3 upon T2, there must be, but I had written by mistake, there is a T1. Now next is a 3, 4, 5, 6, dash dash. These are the terms of the sequence. Here T1 is equals to 3, T2 is equals to 4, T3 is equals to 5, T4 is equals to 6. Now R is equals to T2 upon T1, that is equals to 4 upon 3. Next R is equals to T3 upon T2, then you are getting the 5 upon 4, and next is a T4 upon T3, that is a 6 upon 5. Again by mistake I had written I had changed it, T4 upon T3, that is a 6 upon 5, and the ratio is not constant. From 1 to 3, the ratio is not constant. Therefore, the given sequence is not in GP. The last year you learned the arithmetic progression. In AP, the difference was constant, but here the ratio is constant. The given ratio is not constant. Therefore, it is not in GP. Also, we want to, that is, next is 7, 14, 21 and 28. Now see this, T1 is equals to 7, T2 is equals to 14, T3 is equals to 21, T4 is equals to 28. Now see this, R is equals to T2 upon T1, that is a 14 upon 7, that is equals to 2. T3 upon T2 is equals to 21 upon 14, and the ratio is 3 by 2. Next R is equals to 20 T4 upon T3, that is the 28 upon 21, that is a 4 upon 3, and everywhere the ratio is not constant. Therefore, the given sequence is not in geometric progression. Is not in GP. Question number 2. For the GP, if R is equals to 1 by 3, A is equals to 9, then find Tn. Therefore, Tn is equals to A dot R raised to n minus 1. Now, Tn is equals to A into R. R is 1 by 3 and bracket raised to 7 minus 1. Therefore, 9 into 1 upon 6 bracket raised to 6. That is bracket raised to 3 means 9 into 1 upon 3 raised to 6. Therefore, 3 square upon 3 raised to 6. That is 1 upon 3 raised to 4, and that is nothing but 1 upon 81. This is the 7th term. Now I am completing, that is, we want to find out the nth term in the first question. Now we'll find here. That is, A is equals to 2, R is equals to 3. The given sequence is in GP. Therefore, we can find out the nth term. Now see this. This is a very simple formula. Tn is equals to A into R raised to n minus 1. A is 2, R is 3 raised to n minus 1. And this is the nth term of our first GP. Now the next is here. Again, this second example was also in GP. A is equals to 1. R is equals to minus 5, Tn is equals to A into R raised to n minus 1. The value of A is 1 and R is minus 5 bracket raised to n minus 1, and that's why you are getting the Tn is equals to minus 5 bracket raised to n minus 1. This is the nth term for the second example. See this. Now the next is for the third example. Here A is equals to root 5, R is equals to 1 upon 5, therefore the Tn is equals to a into r raised to n minus 1. Therefore, Tn is equals to root 5 into 1 upon 5 raised to n minus 1. And this is the nth term for that example. Now we'll see the next question number 2, continuation. If a is equals to 7 upon 243, r is equals to 3, then find T6. Now what is our formula? Tn is equals to a into r raised to n minus 1. Substitute the value of a, that is a 7 upon 243 into 3 raised to n minus 1. Now here we require the T6. Therefore n is replaced by 6. Therefore T6 is equals to 7 upon 243, 3 raised to 5. And the value of the 3 raised to 5 is again 243. 243, 43 get cancelled. Therefore T6 is equals to 7. Third example, if r is equals to minus 3 and T6 is equals to 1701, find a. Now see this, the formula a. Tn is equals to a into r raised to n minus 1. Therefore the T6 is equals to a in bracket minus 3 bracket raised to 6 minus 1. Therefore 1701 is equals to a in bracket minus 3 raised to 5. Therefore a is equals to 1701 upon minus 3 raised to 5. And that comes the 170 upon. That comes a is equals to minus 7. I forgot to write out. That is a 170. 1 it must be there. Next is when if a is equals to 2 by 3, T6 is equals to 162, then find the value of r. Therefore T6 is equals to 2 by 3 into r raised to 6 minus 1. But we have given the T6, which is a 162. 2 upon 3 into r raised to 6 minus 1. Therefore 162 into 3 upon 2 is equals to r raised to 5. Therefore it becomes 81 into 3, that is r raised to 5. And this is nothing but 81, that is a 3 raised to 5. 81 means what? 3 raised to 4. Therefore r is equals to 3, the ratio. Now next, which term of the GP, that is a 5, 25, 125, 625 is 5 raised to 10. Now see this, the first term a is equals to 5, T1 is equals to 5, T2 is equals to 25, r is equals to 25 upon 5. Now here the common ratio is 5. Tn is equals to r into r raised a into r raised to n minus 1. 5 raised to 10 is equals to 5 into 5 raised to n minus 1. Now here 5 raised to 1, and by using the law of indices, 5 raised to 1 plus n minus 1, that is equals to 5 raised to n plus 1 minus 1 get cancelled, and then you are getting the 5 raised to 10 is equals to 5 raised to n. Therefore n is equals to 10. Therefore it is a 10th term of GP is 5 raised to 10. That is a T10 is equals to 5 raised to 10.
Now for what value of x? The terms 4 upon 3, x, 4 upon 27 are in GP. Now here T1 is 4 upon 3, T2 is x, T3 is equals to 4 upon 27. The ratio is constant because the given terms are in GP. Therefore T2 upon T1 is equals to T3 upon T2. Therefore x upon 4 upon 3 is equals to 4 upon 27 whole divided by x. And that's why x cross multiplication, by using the cross multiplication you will get x square is equals to 4 upon 27 into 4 upon 3 is equals to 16 upon 81. And therefore x square is equals to 16 upon 81. Taking the square root on both sides, you will get x is equals to 4 upon 9. Therefore, the value of x is 4 upon 9.
Now see this, the next example. If for a sequence Tn is equals to 5 raised to n minus 3 upon 2 raised to n minus 3, then show that the sequence is a GP. Find the first term and the common ratio. Tn is equals to 5 raised to n minus 3 upon 2 raised to n minus 3. Now the terms are T1. Replace n by 1. For the first you will get 4 upon 25. For the second, replace n by 2. Then you will get T2 is equals to 2 upon 5. Now what is the ratio? That is a T2 upon T1 is equals to 4 upon 25. That is a 2 upon 5 into 25 upon 4, and that's come 5 upon 2. Therefore the common ratio is T1 is equals to A is equals to 4 upon 25. Now the next is find the three numbers in GP, that is the three numbers in GPB such that their sum is 21 and sum of their square is 189. Now let the three numbers in GP be A upon R, R, AR, as their sum is 21. Therefore A upon R plus AR is equals to 21. Therefore A in bracket 1 upon R plus R plus R, 1 upon R plus 1 plus R is equals to 21. Now by the second condition, A square upon R square plus A square R square is equals to 189. That is a sum of their square. Take A square as common, then you will get A square in bracket 1 upon R square plus 1 plus R square is equals to 189. Now the sequence, now the squaring equation 1, that is A in bracket 1 upon R plus 1 plus R is equals to 21, whole bracket square is equals to 21 square. That's you will get A square in bracket 1 upon R plus 1 plus R bracket square is equals to 441. Therefore A square in bracket, now square this, that is 1 upon R plus 1 plus R bracket square, that is equals to A square plus B square plus C square plus 2AB plus 2BC plus 2AC. Now I am writing this formula, remember this formula. That ABC bracket square is equals to A square plus B square plus C square plus 2AB plus 2BC plus 2AC plus 2AC. There must be, had small mistake is there, plus 2 times AC must be there. Therefore A square in bracket 1 upon R square plus 1 plus R square in the next bracket, A square in bracket 2 upon R plus 2R plus 2 is equals to 441. Therefore A square in bracket 1 upon R square plus R square, that is plus 2A. Take the 2 as common. a square in bracket 2 upon r plus 2r plus 2 is written in this manner. That's a 2a in bracket a in bracket 1 upon r plus 1 bracket complete is equals to 441. Now from 1 and 2, what are the values? A in bracket 1 upon r plus 1 plus r is equals to 21. Now this value is from the second, the value is 189, and from first the value is 21. That is equals to 441. Therefore, now we will simplify this. That is a 21 is common. That is a 21 in bracket 9 plus 2 is equals to 441. Therefore, a plus 2a is equals to 441 upon 21. That is equals to 21. Therefore, 9 plus 2 is equals to 21. Therefore, 2 is equals to 21 minus 9 is equals to 12. Therefore, a is equals to 12 upon 2. Therefore, a is equals to 6. Therefore, from 1, a in bracket 1 upon r plus 1 plus r is equals to 21. Therefore, 6 in bracket 1 upon r plus 1 plus r is equals to 21. Now substitute the values. 2 in bracket 1 upon r plus 1 plus r is equals to, divide by on the both side by 3. Now simplify this. That is a 2 is multiplied with 1 upon r plus 1 plus r. That is a 2 upon r plus 2 plus 2r equals to 7. Now multiply on both sides by r. Therefore, you will get both sides by r. Therefore, r in bracket 2 upon r plus 2 plus 2r is equals to 7 into r, and that's why you are getting r up 2 upon r into r plus 2 into r plus 2r square, that is equals to 7r. r get cancelled. Therefore, you are getting the 2 plus 2r plus 2r square is equals to 7r. Therefore, 2r square plus 2r minus 7r plus 2 is equals to 0. Therefore, 2r square minus 5r plus 2 is equals to 0. And that's why that is a 2r square minus 4r minus r plus 2 is equals to 0. Now factorize this. That is a 2 into 2, 4. Therefore, the factors are minus 4r minus r. Take the common. That is in first bracket you will get r minus 2. In second bracket 2r minus 1 is equals to 0. Therefore, r minus 2 is equals to 0 or 2r minus 1 is equals to 0. Therefore, r is equals to 2 or r is equals to 1 upon 2. Therefore, when r is equals to 2, a is equals to 6. ar is equals to a upon r is equals to 3 and a is equals to 6. A upon r, ar, that is a 12. That is a 3, 6, 12. These are the terms of the sequence. Therefore, the terms are a upon r, a upon 1 upon 2 is equals to 6 upon 1 into 2 upon 1, that is a 12, 6 and 3. Therefore, the terms are 12, 6, 3. First, they were 3, 6, 12 or 12, 6, 3. Find the 4 numbers in GP such that sum of the middle 2 terms is 10 upon 3 and their product is 1. Now see this, the four terms are in GP, that is they are a upon r cube, a upon r, ar raised to 3. That is the sum of the middle terms. That is the 5 by the first condition. By using the first condition, a upon r plus ar is equals to 10 upon 3. If you take a as common, then in bracket you will get 1 upon r plus r is equals to 10 upon 3. By second condition, that is a upon r into ar, that is the product is 1. Therefore, a square is equals to 1. Product of all terms, that is a upon r cube into a upon r, ar into ar raised to 3 is equals to 1. Therefore, a raised to 4 is equals to 1. Therefore, a is equals to 1. Here there may be the one confusion that the product of the middle term, if you take the product of middle term, then it is different one. But the product of the all the terms, therefore I had considered in the second case the product of the all the terms. Therefore, a raised to 4 is equals to 1. Therefore, the sum of the middle two terms is a upon r plus ar is equals to 10 upon 3. That is sometimes the language in the problem is confusion. That is the first, they must give the product of the all the terms is 1. But if they give the sum of the middle term and then write the product, their product, then there is a confusion between the students. Therefore, now simplify this equation. That is a multiply on both sides by r. That is r in bracket 1 upon r plus r. That is equals to 10 upon 3 into r. Normal simplification is there. That is 1 plus r square is equals to 10r upon 3. Therefore, multiply on both sides by 3. 3r square plus 3 therefore by multiplying on both sides by 3, then you will get 3r square plus 3 is equals to 10r. Now this is the simple quadratic equation, 3r square minus 10r plus 3 is equals to 0. The product is 9 and the sum is minus 10. Therefore, 3r square minus 9r minus r plus 3 is equals to 0. Therefore, take 3r from the first two terms and minus 1 from the remaining two. Then you will get r minus 3 in first bracket is equal and second bracket 3r minus 1. Therefore, r minus 3 is equals to 0 and 3r minus 1 is equals to 0. Therefore, r is equals to 3 or r is equals to 1 upon 3. If r is equals to 3, a is equals to 1, then the terms are a upon r cube, that is a 1 upon 3 cube, that is 1 upon 27, a upon r, that is a 1 upon 3, ar, that is a 1 into 3, and the last is ar cube, that is 1 into 3 raised to 3, that is a 27. Therefore, the terms are 1 upon 27, 1 upon 3, 3 and the 27. These are the terms. When r is equals to 1 upon 3, r is equals to 1 upon 3, a is equals to 1, then the terms are a upon r raised to 3 is equals to 1 upon 1 by 3 bracket raised to 3 means what? It's multiplied and reciprocal and therefore it becomes 3 raised to 3 is equals to 27. A upon r, that is a 1 upon 3 and that's becomes multiplied and reciprocal. That is, the multiplied and reciprocal means what? 1 into reciprocal of 1 upon 3. Then what is the reciprocal of 1 upon 3 is 3. That is 1 into 3 is 3. And next is AR. That is the 1 into 1 upon 3. That is 1 by 3. AR cube. That is the 1 into 1 by 3 bracket raised to 3. That is the 1 upon 27. Therefore, the terms are 27, 3, 1 upon 3, 1 upon 27. Hence, required numbers in GP are 1 upon 27, 1 upon 3, 3, 27, or 27, 3, 1 upon 3 and 1 upon 27. These are the numbers. Now see this answer. Now the next question. Find the 5 numbers in GP such that their product is 1024 and the fifth term is a square of the third term. Now see this. The 5 terms are in GP. They are written in this manner. That is A upon R square, A upon R, A R square. By the first condition, that is their product, that is A upon R square into A upon R, AR into AR square, that is equals to 1024, their cancellations. Therefore, you will get A raised to 5 is equals to 1024 and A raised to 5 means what? That is 4 raised to 5. Therefore, A is equals to 4. Now, by the second condition, that is AR square next is by the second condition, AR square is equals to A square. Therefore, that is the fifth term is the square of the second term. Therefore, AR square is equals to A square. Therefore, R square is equals to A. R square is equals to 4. Therefore, R is equals to 2. Therefore, now A is equals to 4, R is equals to 2. Now the terms are A upon R square, that is a 4 upon 2 square, that is a 4 upon 4 is 1. A upon R, that is a 4 upon 2, that is equals to 2. Next is A is 4, AR, 4 into 2, that is 8. AR square, that is a 4 into 2 square, that is a 16. Therefore, the required terms are, that is 1, 2, 4, 8, 16 or 16, 8, 4 to 1. But it is not necessary to write the second one, that is the required terms are 1, 2, 4, 8 and 16. Because the value of the R is 1. The answer in the textbook given, that is in the 2 manners, but here is not required. The value of the R is single one. Question number 9. The fifth term of a GP is X, 8th term of the GP is Y, and the 11th term of a GP is a Z. Verify whether Y square is equals to XZ. Now we'll see this. Tn is equals to formula A into R raised to n minus 1. T5 is equals to A into R raised to 5 minus 1, that is equals to X. Therefore, A into R raised to 4 is equals to X. That is a T8 is equals to A into R raised to 8 minus 1, that is a A R raised to 7, that is equals to Y. Therefore, A R raised to 7 is equals to Y. Now T11, A into R raised to 11 minus 1, that is A R raised to 10. Therefore, A R raised to 10 is equals to Z. Now what is the relation that we want to prove? That is X, Y, and this is the Z. First, second, and this is the third one. From first, second, and third, that is y square is equals to xz. Now see this LHS, y square is equals to a into r raised to 7, bracket square is equals to a square r raised to 14, and that is written in this manner. A square r raised to 14 it is written in this manner. A into r raised to 10 into a into r raised to 4. Therefore, y square is equals to zx. The value of z is a into r raised to 10 and x is a into r raised to 4. Therefore, y square is equals to xz. Now the 10th question. If P, Q, R, S are in GP, then show that P plus Q, Q plus R and R plus S are also in GP. Now P, Q, R, S are in GP. Therefore, P upon Q upon P is equals to R upon S is equals to S upon R. Now consider Q upon P is equals to R upon Q is equals to S upon R is equals to K. Therefore, Q upon P is equals to R upon Q. Therefore, by using the theorem on equal ratios, now see this that you have learned in the 9th standard, that is a value of the each ratio is equals to K, then Q upon P is equals to R upon Q is equals to K, then the sum of the numerators plus the sum of the denominators, that is the Q plus R is equals to, that is Q plus R upon P plus Q is equals to K. This is one. Also, by the next condition, that is R upon Q is equals to S upon R, that is equals to K. Again, by the applying the theorem on equal ratios, you will get R plus S upon Q plus R is equals to Q upon R is equals to S upon R is equals to K. This is the second. Therefore, from 1 and 2, you will get Q plus R upon P plus Q is equals to R plus S upon Q plus R, and hence it is proved. Now in this way I had completed up to the question number 10. I hope that you had understand all the answers whatever I had given. It means that the P plus Q, Q plus R, R plus S are also in GP because their ratio is a constant. In this way, I had explained all the examples, example 1 to 10. I hope that you understand. You will understand all the problems. If you have any again doubt, then write in the comment box. I will try to solve your difficulty. Now we'll see in the next video, that is the exercise 2.1 and the remaining questions, that is the question number 11 to 15. Till then, goodbye.